Okay, so now that we've successfully created the trellis kind of structure here with the rafters, we can see that if we come here, we can also increase or decrease, the spacing on it, depending on what we want. So let's get that to a nice one where it kind of all fits together. And there we go, something like that. And now what we want to do is actually create, some cool pattern here at the top of the trellis. That way we can, make it a more dynamic and fun design. So to do that, let's go ahead and come back here where we have these planes that we created with the contours. So let's go ahead and do a space bar and let's preview these and see that these are the ones that we actually created the rafters from. And so these two, we want to use this component here under the tab intersect. We'll come here to physical and we want to do brep with brep, and we want to plug in that surface, we want to plug in this surface, and the result is going to be, let's see, if we go here to flatten on one side, we see that it'll actually create a line exactly at that intersecting point. So let's go ahead and take these and hide them, just because we don't want those to get in the way right now, because we want to be able to see these lines that we just created. Now let's go ahead and also bring in back here where we exploded this. So we have the rafters, right? And right there on the rafters, we extracted this box, which then we extracted the curves for the directions. So now we want to also extract a face. We want to extract the top face here so we can intersect these curves with the top face. So let me show you that. I'll go to list item because I want to pick one of the faces, and I don't want to pick one of the edges like I did before. I want to pick one of the faces, and the default face that it gives us is the side one. But like I said before or earlier in this lesson, if we go here to reverse, it'll actually give us that top surface. So we can take that top surface and these lines that we have here and go here to intersect and go to brep curve. And so that's what we want to do. We want to take these curves and where they intersect with this brep, we get a set of points. And so if you haven't noticed by now, what we're doing is basically deconstructing things and using the geometry that we've created before to place together or intersect things to extract information that's going to be useful for us to use for creating a cool pattern that is all encompassing and it kind of all works together. So when I play around with the spacing here, let's say I go to a 36, the lines here, or the spacing in between the points, is going to change accordingly. So everything is kind of tied together in a nice way. So let's go ahead and leave that there, and we have these points. Now with these points, we can go actually go ahead and go to polygon. So let's double click here and go to polygon, or we could use circles, but for now we'll use a polygon. We'll say we'll keep it with a radius of, I'll say 12 for now. The segments, we'll say it's a 4-sided polygon. So go to double click and do 4. And the plane is going to be actually the points. So it's going to create that polygon exactly at all of those points. And now we can use this along with the original surface. And now we can even come here and increase the size of the spacing there, and we can do a Boolean difference of these. So let's go ahead and do that. Let's do a boundary surface of the polygon. Okay, so basically what we want to do is, now that we have these polygons here and we have this surface, the best way to get the pattern right on this surface would be to extrude this one first, and we'll extrude this one the same amount, and then we'll do a Boolean difference. Because doing it other ways of with planes, it's a little bit tricky. So let's go ahead and extrude this surface here. We want to take that and extrude it. We want to go in the Z direction, and this is going to be the thickness of our trellis. So let's go ahead and pick, let's say, a 3-inch thick trellis. And so there we have that. And we want to do the same thing for these boundary surfaces. So I'm just going to take this, slide it, do Alt, and make a copy. And then we can plug those surfaces right into the base there. And there we have both of those. So we can go ahead and hide the base surfaces that we extruded it from. And we can now take the A, which is the surface, and then B, which is the pattern, and we can do a difference. So let's go solid, difference, and we take that surface and those sets of solids, and it's going to give us a weird result, but that's because this is not grafted. So what we want to go here is actually flatten it, so not graft it. This means that there's a lot of information coming in different sets, and so what we want to do is flatten it. That way it just looks at it as one straight set, and it'll give us the result that we want. Now it'll take a little bit of time because it's doing it, it's creating a difference of all of those solids, and so it'll take a little bit of time. But once we get that result, then we can go ahead and select those, spacebar, and then unpreview, and there we have our trellis that we created. So we have, our columns, we have our beams here, then we have the rafters above, and ultimately we have the top trellis here, the trellis pattern. And we can actually come back here and where we have the overhang. So let's go back here and check out where we have the trellis offset. So we have it at 36, so we can do 12, and we'll see that the overhang will adjust. And like I said, it'll take a little bit of time because it's doing all of those subtractions, but everything's going to be 100% accurate, and you can use this for any design. And you could always adjust the pattern according to whatever you want. So right now we have polygons, but we could use circles, or we could use different shapes for creating this top structure. So right now it actually kind of clipped it a little bit. So I think if we come here and we actually do a 24, it might be a little bit better, so it doesn't trim out some of the outside part of the pattern here.